Hello everyone, let's look at a couple problems that I think are going to be really important to you for using the right-hand rule to determine the direction of these vectors. So, if we have our equation, force equals the charge of a particle times its velocity times the magnetic field that it is subjected to. So this is our equation here, and it always has to be V times B. You can't switch it to B times V. That doesn't work. So just make sure you're always following this. Okay, so a couple things. This equation is used for a moving charged particle. So the charged particle has to have some velocity. It can't be still. And the two kind of denotions that we use, if we're going into the page, we use this little X symbol. And if we're coming out of the page towards us, we use just the dot. Okay. Also, let's kind of take a little bit of a logical approach to this. So the way that these vector problems work is by utilizing all three dimensions. So if one of these vectors, say velocity, takes the up and down dimension, and another vector, say the magnetic field, takes the right and left dimension, the only possible dimension for force to be in is either in or out. The force cannot be directed at any kind of way. That can't work. It has to be either in or out. Okay, so with that in mind, let's start solving these. So, the way that I like to solve them is considering all of them as positive and then changing our answer if it actually is negative. So in part A, this is a positive charged particle, and you always have to use your right hand. You can't use your left hand. So your thumb, as this image shows, is going to be velocity. Your fingers are going to be the magnetic field B, and the direction that your palm is facing is going to be the direction of the force. Also, this image does a really good job at showing what the angle is between. The angle is between velocity and the magnetic field. So with that, the force is perpendicular to the plane that both of those create. So in part A, using your right hand, put your right thumb in the direction of the velocity and have your fingers go in the direction of the magnetic field B. So if you're doing that correctly, you'll get that the force on this proton, this positively charged particle, is directed out towards you. So if your thumb is down, your fingers are to the right, your palm should be facing towards you out of the page. Okay. And now let's look at B. So we have a positively charged particle. We have the velocity directing up and to the right, the magnetic field going into the page. So if we were to draw the vector of force, it would be like this. This would be the force on that particle. And the force is perpendicular to the velocity and the magnetic field. Okay. Part C. So here we're introduced to a negative particle. And let's just start by treating it as if it were positive and then switching our answer. So velocity, our thumb is directed downward, kind of just like part A. And B, our fingers are directed to the right. So the force appears to be coming outward, but because it's a negative particle, the force is reversed. So instead of the force being out of the page, the force is actually into the page. And that's just because it's a negative particle. Okay, and now let's look at part D. So again, we have a negative particle. Our velocity, our thumb, is coming out of the page towards us. Our fingers, our magnetic field, is down and to the left, and our force is going to be coming out of our palm, like that. That is the direction of the force. Okay, so for part E, these last two are a little bit tricky because we're given force, but we're missing the other vector that we're kind of used to being given. So we have a negatively charged particle here. Let's consider this. So the force is supposed to be coming out of the back of our hand rather than our palm. So if we take our thumb and point it towards us out of the page, and we have the back of our palm facing the force, our fingers will then direct us in the direction of the magnetic field, like that. So this one's particularly tricky because we have a negatively charged particle and we're given force. Okay, and our last one. So if we have our palm facing upwards and our fingers facing to the left, we can see that our velocity will be directed into the page, like that. All right, and that pretty much sums it up. They're all very similar to each other. If you get the hang of a couple, you'll always be able to do any other ones. So thank you for watching.